You can start now.
Okay.
Good luck.
Thank you so much. So first, let me start with a short recap of our project, InkSight. So what we did for the last couple of months was to engineer a living biomedical tattoo that can signal physiological changes inside of your body. So for that, we engineered mammalian cells and embedded them in the hydrogel. Here, they can sense biomarkers in the interstitial fluid by using the synthetic receptor MESA. Then a contrast change is induced thanks to our synthetic melanosomes. These are made of encapsulants that are derived from bacteria. And inside we have our tyrosinases that can synthesize melanin to actually induce the contrast change. So what did we achieve since Wikifreeze? Let's start with the encapsulants. So one of our contrast change strategies is based on assembly. And for that, we designed pro-encapsulants where the monomers are fused to a steric hindrance domain that has to be cleaved off by a protease to induce assembly. We already showed that that is possible for our MX Pro encapsulant. So once you add TEF protease, you see that the nanocage assembles. But now we have new data indicating that that's also true for another Pro encapsulant, which is the QT encapsulant. So here you can clearly see without a TEF protease, you have the monomers. But once you add a TEF protease, the monomer then disappears and you have an assembled nanocage. But even more exciting than that, we also tested our fusion encapsulants. So here we directly fuse the tyrosinase to the encapsulated monomers so that once they self-assemble, we already have the tyrosinases inside of our nanocages. So this is completely novel. It was never tested before, so we were very excited about it. We already saw that they do assemble, even though we have a tyrosinase fused to the N-terminus. But now we wanted to see, is the tyrosinase still active? So for that, we measured absorption to see melanin production. We have a negative control, which is an empty nanocage, and the positive control, which is a nanocage that was loaded with tyrosinases after assembly by using a cargo signal, which is a classical way of doing it. And then we also tested our fusion encapsulants. We could see activity for both, but what's really amazing is that we have a 5-fold increase for MX fusion encapsulant compared to our positive control.
All right. Now let's talk about the amazing MESA receptor, which makes our tattoo applicable to almost any target. To bring this wide availability to the synbio community, we created MESA Designer, our software tool. Now let's walk through how this actually works. First off, you start by selecting binding domains for your antigen. This tool searches through over 10,000 experimentally validated sub-dub structures to provide you with available chains. The next step is selecting transmembrane domains. We compiled available experimentally validated data and give the user a selection that's usable for most use cases. The interesting part is your system's output, the intracellular domain. Here, you can do almost anything with MESA. However, for most applications, you're going to want to release a transcription factor or a reconstituted TEF protease. So these are the options that we, while customizable, provide to the user. Finally, you have 4 further options for experts and different use cases. And you have the option to perform sequence optimization to iGEM BioBrick standards. And you can then go ahead and download and drag and drop that GenBank file directly into Genius Prime or any other editing tool you want, or you can go ahead and directly order your G-block from any website. Let's talk about how we experimentally validated the system. The setup is the exact same for all of our MESA experiments. We have the dimeric receptor with the split TEF protease, which upon reconstitution reconstitutes and cleaves itself, releasing itself intracellularly. This can then cleave our membrane-bound TTA transcription factor, which is imported into the nucleus and causes YFP expression. We use yellow fluorescent protein as confirmation for our MESA activation. Let's talk about the results. Here you can see the results for our IgG1 Fc domain receptor. On the left-hand side, you have it without any IgG1 present. You can see there's barely any fluorescence. On the right-hand side, you see the results for IgG1 induced expression, and quantified analysis showed us 160% increase in fluorescence between these two states. Thank you very much. Do you have any questions?
Yeah, so first of all, congratulations on the great project.
Thank you.
You made this progress so far. And yeah, like the remote judges, do you mind starting with your questions?
Yeah, sure. Hello, everyone. I'm Jessica, and I'm a remote judge. And you can read my question in the chat. First of all, thank you for your presentation. And I would like to ask you, what is the next step you have planned for your project in the next months? Thank you.
We found a chat. So we have many next steps planned. So we have 3 compartments basically, and all of them can be still improved. So let's start maybe with our software validation. So we tested it with a antibody, but we would also really like to test it with progesterone, since that is one of the targets that we looked into. So we're really, really nice to see if that also works as well as with the antibody. Then also, we looked into tyrosinases, for example, where we did some experiments, but we would still like to do further research on that to see if we can maybe still optimize their activity. We have, for example, what we showed you before with the fusion encapsulins, we saw that we have a high activity in those, but maybe a high activity is not what we need, or we want to have a little bit less of it to not have too much melanin production. So there are a lot of things we would like to improve, but a general goal we would have in the end is to maybe have a system where we have, for example, an agarose block, and we can actually implement our tattoo into the agarose block to see if I add the biomarker, will it actually change contrast? Is it visible? How quick will it respond? Just to have all of these parts that we tested separately together.
Additionally, for our software feature-wise, we talked to Professor Joshua Leonard recently, and he identified some key features that might be interesting, that might also make this tool available as an educational tool. And he said, quote, "I love it." And that's especially what we're going to focus on. We mentioned it on our wiki as well. We're currently working on a high performance version, which has all the tools that currently are only implemented with the Python and REST API, only for programmatic use. We want to include those on workstation machines with high performance compute available, also on the web GUI. So that's where the software is headed.
And if I may add to that, apologize, I'm online, I'm sick. Regarding the hydrogel, because that's also a very integral part of our system. We have not tested anything so far, but if we were to go forward with this project, it would be very crucial to start testing systems for their how suitable they are to our system potentially, what restrictions there are, and also from an HP perspective, which I think is very important as well. It was really great to, for example, talk to potential users of the technology, and I think we would have to expand a lot more on that, because that yielded a lot of really interesting insights for us that I think are going to change the conceptualization probably even further, depending on the target and so on.
Thank you for the question.
Thank you, team, for your answer, and good luck for your project.
Thank you so much.
Rodrigo.
Yes, hello. I have no questions. I think it's a great project overall. So if we can move on. Oh, wait, I want to congratulate the team too, because it's a fantastic project. And I think it was a very original idea.
Thank you.
So, how did you quantify melanin production of the color change?
How did you quantify melanin production in your color change?
So,
Maybe.
who was it? Microphone?
So, in what experiment? We performed the experiment that we showed in the wiki with the lit tyrosinase, where we basically purified the tyrosinase using a struct column, and once purified, we verified the purity with SDS page, analyzed the concentration with nanodrop, and then we basically performed the tyrosinase assay with the standard kit that we had, and there we basically had two different samples, one where we added a TAF protease, or another one where we didn't add a TAF protease, and we were able to see the 6-fold increase in activity of the TAF protease, of the tyrosinase after addition of the TAF protease, which is what we basically wanted to do. The way we measured this is with a plate reader. We had 96 well plates with all of the different tyrosinases that we were looking at, and we were first able to see the melanin production with the naked eye, as you can see in the well. In the sample where we added the TAF protease compared to the one without. And then we used a plate reader to basically measure absorption at 500 nanometers, and that's where the data basically comes from.
If I can add to this question, I was going to refer to this figure.
Yes.
Do you do any replicates?
Unfortunately not. The purification process with the equipment that we had available in the lab was very, very tricky and very time consuming. We actually tried reperforming it so that we could update you here, but it was rather unsuccessful, unfortunately. So we would need triplicates. We really do. That's why even if this data looks very, very promising, there's still some work missing. But also the purification process itself for the other tyrosinases needs to be optimized. So this one is a lit tyrosinase. They are generally very, very big, but especially if we look at the split tyrosinases, there we have smaller fragments because it's basically half a tyrosinase size-wise. And in the STS page, we were not able to clearly see them because they're at the bottom. So basically here, and it's very difficult to really understand which band is the one that is interesting to us. So there we maybe need some optimization. We could potentially try to use a different concentration for a gel. That would be basically the first approach, but we didn't have it available in the lab where we are hosted, and ordering it was no option after in such a short time frame, basically. So yeah, that's something that is planned as well, but not done yet.
Okay, so I have two questions. My first question is, do you think that this would work on darker skin?
So this is actually one of the limitations we're facing right now. So of course, the contrast change only works if you have something that the melanin is like contrast to. So we're using it right now as a proof of concept as well because it's just one enzyme. So we have a reaction that's pretty easy for our nanocages. We looked into more pigments because we also have the issue, we want to also be an art project. So it would be really great to also have some color in there, make it more artistic. Our problem here is that most of them have at least 5 enzymes in their reaction. So I'm pretty positive that you can engineer it. There are like many, many enzymatic engineering steps where you can substitute 5 enzymes with 1 enzyme, but we decided against trying that just out of the time frame. So that is something that we would look into because of course, right now it's not as inclusive as we would like it to be. But unfortunately, we did not have the manpower or the time to do enzyme engineering.
Okay. My second question.
If I might add to
Yeah.
that, so we actually also, in our research, we identified, for example, indigo iodine as a very promising pigment. However, we have a model which, when we modeled the absorption of a nanocages, dependent on of a hydrogel with a cell suspended, dependent on the number of nanocages, and it just showed us that it's really dependent on the absorption and that the pigment has to be potent. And in purely biologically produced pigments, there is nothing that can outcompete melanin with this. To this regard, melanin has a very broad absorption spectrum, and the extinction coefficient is very much higher than in other pigments that are bioproducible.
Okay, so my second question, thank you. My second question is regarding the software. Who's the software person? You're the software person. Okay. So my question is, I like your software. You know, I work with. I'm actually very good friends with Josh. But I so work with Mesa. I work with, you know, the SINAT and all that. But I'm wondering is with respect to your software, does it also give you the distance from the 2 parts? Because you talked about all the parameters that it was able to give. Can you pull that one of your slides up? So we can. I'm very visual, so if we could just kind of talk about that a little, yeah.
Guess you're referring to, well, let's use this. Yeah.
Anything, yeah, this works, yeah. And so, because you talked about the software, you know, finding sort of the binding sequences and, you know, searching through all of the data and stuff. But what I'm wondering is if you found that the distance between the 2, is there like an upper limit, lower limit?
So in terms of what the software does, is by searching through SubDup, these structured database, you already get antibodies, which then obviously have a very, very
Yeah.
low distance between these two sequences. If you go the route of Minecraft creation, then you have to obviously check out what that actually looks like. This is what I mentioned earlier, what we're still working on with integration of high performance tools in the software directly. Right now, you would, for example, if you're using the Python package, you could say, okay, I create my Mesa receptor pipeline where I then use the created structure through an AlphaFold prediction, and then I measure the software, the distance using the software again. So that's that. The other thing that we're working on is like a global scoring function, right? Because a lot of the Leonard papers have comparisons of TMDs, et cetera, but there's no integrated algorithm for computing the total score of the entire construct. That's also something we're working on. Does that answer the question?
So I'm just, this is a purely sort of a pragmatic question in terms of like, if I go on the software and I'm like, oh, I'm so excited. I want like, this is the epitope I'm looking for, or this is like my target or whatever. Is it going to give me 5 options of the same thing, but just how many, what I'm wondering is if this is one of those parameters that would increase the number of,
available options?
Yeah, or even just like the things that I would have to order, like to synthesize, like would it?
So if you, okay, I think I understand the question. Yeah.
I can try again if you understand my question.
Okay, yeah, no worries. So right now we're searching subtype, right? So we get these structures, and they are like EM structures, so they're pretty fixed, right? It returns to you everything that relates to your search. So this can be depending on how specifically you search 3 structures, anything to 25. But then if you want specific distances, you would have to go with the integration of the other tools. Yeah.
And so if my parts didn't work, I would just go back to the software.
Right. But then I would encourage you to like build this pipeline where you can go through 10,000 structures.
Incredibly useful tool.
Thank you.
For the field. And so that's why I'm like, oh, I actually I sent the link to one of my colleagues.
Did you try our demo?
Wait, I just sent it to him last night, and we're writing a grant together, and I was like, look, and anyway, so so we had all these questions. So anyway, I was just thinking of it from a purely like usable, but it's a great tool.
Yeah, no, but I think once we get the global scoring function working, that's
okay. Awesome.
Thank you.
Sorry.
Congratulations on your project. So my question is about how are you going to ensure that the system can be reset or the tattoo will fade? Mostly because of medical privacy, because of somebody might see it and well, some of your information can be seen to the public.
So concerning the aspect of privacy, we actually did a survey where people also ask us, and we're like, okay, what is if people see that? And I'm basically like, maybe if I use it for troponin, for example, what if I'm marked as a ill person? Maybe I don't want that. So what we would do here is we would have many motives that the person can choose themselves. So if we're not using one tattoo, but many different tattoos, that way it will not be received as a medical tattoo immediately. So that would be for the privacy. Would you like to add to that?
Yeah, maybe like this whole ethics aspect. I mean, privacy is a big concern, right? Also, as Emma mentioned wonderfully in our survey, so we also addressed it in our policy analysis. So for us, we strictly advertise to use this in like a custom made project. I mean, we have this creativity in this whole project. We have that you can choose the motive yourself, so you don't give yourself away. Also, because we understand that there is a big problem with like giving away biological data, but it is important for us to note for you that we don't store any data. There is no app or software to give away data, so there is no storage and no data that is flowing around. So it's just, you know what this tattoo means, and maybe you can give away to the medical professionals that you are talking to, but it's we don't force anybody to have this tattoo, and it's completely up to the user.
May I add to that again? I'm sorry if I'm interrupting. So yeah, that's one point, knowing what the color change or the pigmentation, the change of pigmentation depth actually means. So you, in order to interpret it, you have to know what kind of biomarker the tattoo on another person, for example, you have to recognize it as a biological, like a biosensor, first of all. And then second of all, which is of course very important to the whole conceptualization of how this could work, is that you can freely choose the spot on which you would like to be tattooed with the biosensor. So for example, we talked to some potential or some patients that are currently being treated for heart diseases, and they gave me feedback that one of them, for example, didn't mind having it more out in the open because they were not concerned about the privacy. But others said they like the idea that it could be on a more hidden place, like for example, on the thigh, when not everybody usually sees the spot.
Yes, it was more directed towards for how long will it last? Because it will give me the answer yes, but then for how do you know? Do you have any idea of for how much will be shown? And then also because of depending on on where you decide to put it, you will change the type of cells that you will be working.
So for that, since we're using cells, of course, the important question is how long will our cells survive to be functional? And there, we talked to different experts, and we assumed that they would be viable for 4 months, which would be like a great span. Because, for example, if you are at high risk of having a heart attack, that might be temporary. That does not have to be for your entire life. So getting a medical tattoo that lasts forever for maybe a temporary medical situation might not be ideal. So that made us pretty happy because you want to have a time span where you don't have to get re-tattooed like every week. That would not work, of course, but also not too long. The other aspect, of course, would be definitely the hydrogel, where we looked into it. Unfortunately, we could not work with it, but there are like many, many different options. For example, we would use it as in tissue engineering, where it's also often used and degrades over time. So what we would do is having experiments where we actually could test, okay, that's how long our cells live. And then depending on that, we would have to engineer a hydrogel. And those are the two factors for the living span.
I have a very quick question. Like, why were you placed in a different village? We had a hard time to find you. Yeah, what was the reason? Like, do you know what?
Did you do it? Multiple things.
We still have time. Let's be quick and brief. It
So,
wasn't-
I mean,
yes.
there are inherent artistic aspects with any tattoo project. So this is why we first looked into tattoos. This is also what we mentioned earlier, are there pigments, etc. Also, how it relates to the art competition, visiting tattoo artists, etc. This is why we applied to be in an arts village, but we would have been the only overgrad arts village. And so they moved us to diagnostics. We were then placed in the arts village, requested to be placed in the diagnostics village, however, this was denied. Yep.
I see. Oh.
Yeah, but I think it still makes sense just with how artistic this project can be.
Yeah, I was just curious because we went.
We just got the best of both worlds.
Yeah, because in order to get the tattoo, it will not be a regular tattoo artist, right? You'll have to have some sort of
Yeah.
knowledge about
Mhm.
medical.
You will have some testing. I mean, there is an idea of making a hybrid model of like a tattoo artists which have the knowledge of like how to tattoo skin and how to work with the tattoo guns that we will be using probably, as well as the safe compartment and who is capable of doing this, not only like from skills, but who is like allowed to give tattoos out and like medical professionals. So we envision maybe a future where it is a hybrid model with like medical professionals collaborating with tattoo artists.
If I may add to that, we also visited a local tattoo fair where we talked to artists because we wanted to have that art aspect in the project. And we were actually really surprised because we asked them, would you be willing to do like extra classes in case that would be like necessary? And they were actually really excited. They even thought we would be selling a project that
They were like, when can you sell it to us? We want to be the first ones.
So in your opinion, it's easier to take the tattoos into the medical rather than the medical into the art tattoo and sort of arts type of situation?
So I wouldn't construct us and define us by something. I would just do a hybrid model, to be honest.
But we also clarified with governance experts that if we were to start out with something like this, we would first have to take this into the medical setting. So we would have to start out by collaborating, or well, by getting this into the medical practice and having it applied by medically trained professionals. And the hybrid model is something that we conceptualized or envisioned, but that is even more futuristic than even bringing the whole technology into application. But it's an idea.
Sounds good. Okay, well, I guess time is up, and congratulations again. It's truly inspiring project and yeah, wish you
Thank
good luck. Good
Thanks
luck.
so much.
Enjoy.
Thank you.